This question is from GATE 2014 Mechanical Engineering paper set 2, question number 53. A mild steel plate has to be rolled in one pass such that the final plate thickness is 2/3 of the initial thickness. With the entrance speed of 10 meter per minute and roll diameter of 500 millimeters, if the plate widens by 2% during rolling, the exit velocity in meter per minute is dash. So let's write the given things first. It is given that final plate thickness is 2/3 of the initial plate thickness because the plate is getting compressed thickness wise. Entrance speed is given to be 10 meter per minute. That means the initial speed is given. Let that be VI, will be 10 meter per minute. Roll diameter, let that be dr, is given as 500 millimeters. Also, the strain in width direction that we can write as epsilon W is given as 2%, which can be written as 0.02. We need to find out the exit velocity, that is final velocity VF. Now, in this case, we will calculate the final velocity on the basis of the fact that volume of the plate will remain constant. And particularly here, because the velocity is given, calculations in this problem we are going to do on the basis of the fact that rate of change of volume is constant, that is equal in the final and the initial condition. We can write capital V, volume change per unit time. So this dot denotes change per unit time. It initially will be equal to volume change per unit time finally. Let's substitute. Initial volume can be written as thickness Ti into the width, let that be Bi, into the velocity Vi will be equal to, because we are considering the rate of change of volume, we are taking velocity Vi. For final volume change, we will have Vf dot will be equal to Tf into Bf into Vf. We have to find Vf. So rearranging this, we get Vf is equal to Ti Bi Vi divided by Tf into Bf. Now strain for width will be given as change in width divided by the initial width. That means it is Bf minus Bi by Bi. Therefore, we can derive the relation Bf is equal to 0.02 plus 1. Taking this term on the other side, we get 1.02 into Bi. This Bi which is in the denominator. So we can calculate this ratio Bi by Bf from here, which will be 1 upon 1.02. Let's substitute values for Tf and Bf from here. So we have Ti Bi Vi divided by 2/3 of Ti into 1.02 times of Bi into Vf. Therefore, Vf will be equal to Ti by Ti gives us 1, Bi by Bi gives us 1. It is Vi, that is 10 meter per minute, into 3 by 2 into 1.02. By putting this in the digital calculator, we can get the answer for final velocity or exit velocity as 14.705 meter per minute. Let's go back and put the correct answer. So exit velocity in meter per minute is 14.705. To learn more about metal working processes, you can refer to the NPTEL video Metal Working Processes Rolling from the course Fundamentals of Manufacturing Processes. This course is by Professor D.K. Dwivedi. He is from IIT Roorkee. I hope this solution will help you clear your doubt. Thank you.